This is the first $3
Bob
trillion
Wonderful, you
company
say, huh?
trading in the U.S., probably trading in the world. Just a couple of years after we crossed $1 trillion for the first time, it's now doubled and tripled
So,
that
hey,
level.
mark it down. Amongst trillion-dollar companies at systems, usually that's going to run you about 182, right? If $1 trillion in the market cap, short of any a company X, there should be about 182. That's what that company has in a danger noodle set up in here between here. So fractal that. If it's not, there should be some kind of an algorithm or optics to it. Yeah, here we go. We'll use this. Why not?
Welcome to Electronline.
Let's skip a few bits here. I want to get to a part where it's actually, hey, where did it go? Where you need
if we were to graph the wavelength, then gamma would start kicking in, and the wavelengths would start getting smaller, 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 and you asymptotically, of course, the wavelength would go to zero as you get closer and closer to the speed of light. So that's how, since...
Let's see what they got to say.
Welcome to Electronline.
In the last several videos, we've been looking at the apparent mass of a photon. Not only is there symmetry across the board, it keeps it all on one board. One of the beauty things about MIT is it works that way.
It also acts like it has momentum. The broadly wondered,
what is it? The pricing power of being at Wall Street. Computer's a little bit faster. The lag on the system gives you a little advantage on the system.
Waves just like photons do.
So eventually you want to register that to there with as little time lag as possible in the mods, because usually by tightening that up before the world record speed run starts to have diminishing return problems, numbers thousands of results to any change in your PB or something like that.
A particle that moves very fast, close to the speed of light, then of course we have to say that the momentum is equal to
direct current
gamma times mv, where gamma is equal to 1 over the square root of 1 minus v squared over c squared.
So instead of that, it doesn't matter which way you go because they're the same thing. It's when you put them relatively, special relativity to this. The problem is it causes a causal collapse at 0, 1, and all of it falls to zeros and ones.
Let's say what that would mean if we look at the momentum of a photon.
So here we have a line, different lengths of that line, different masses, proportions that say, well, you said it was going to work if I put a wire to it. Yeah, but you put, a 10 gauge copper wire between the cell phone. That's what you have. There was limits to the bandwidth of that thing being able to glitch through that phase on the polarizing wave function of that index xy to the piece of metal that you're dealing with. Now this is a very long image. You can compress this down to just one symbol. And if you do the model like that, it'll start crossing all this out and again compress it down to 0. Where you get steps, binary lengths of 1s and 0s, or partial derivatives where it registers 1 and 0 the way it's supposed to
lambda. So if we replace
the chapter 2 basics are still going to get you to special relativity. I'm in an elevator with a cable with different weights in it. The zenith on that to correct, not just not crashing the floor or launching off the ceiling, and obviously the brakes on the things, but also the smooth on the clock of the motors, or how big a gears, because at that phase, I mean, I'm sure I could get enough gears and transmissions running and changing directions, angular into potential in such a way that ball bearing factory that
wavelength of a photon
I can make them all out of plastic. But you got some real gypsy Jaeger housing problems on whether that piece of metal is really physically, if you I-beams, if you pick them up with a skid steer, if they're long enough or something, they'll stretch, they'll bend. Stone, they're long enough. It's starting to be over 12 foot. I need different equipment because my regular forks at their widest, because I might need to adjust them small for 3-footers in the bandwidth where the peg is going to be on the timeline. If I'm looking at it with all those options, it's got some probabilities on some trigs. Again, the black body problem, or what you're looking at that is if it's an entire black body problem, or some market index says, well, about high and then kind of coming down, and maybe some people are trying to platform it off there, come in late. There's some different
that the
45s
of
that
particle
would give me that range. And again, I'm going to keep it to the condensed
divided by the mass of the particle
photon gluon. Says the observation said it affected it. It turned black, had a color, increased in temperature. Maybe its color increases in temperature and you need that to change the field so it works in such a way that you need it. You could talk about aluminum as a heat sink, or why it emits it in such a way, turning photons, electromagnetism into thermodynamics.
Times m times v, and of course that would be the rest mass of the particle times gamma. So we can either write the wavelength of a particle like this, or we can write the wavelength of a particle like this, depending upon
identical to this. And you're going to be like, well, don't do it with this guy talking. Why? I mean, there's so many differentials, I might as well make up my own for A0, one condensed A0 and one. Well, I have a model in which I can do that. But it doesn't change the reason why I use mine that way the same way as this. And we could just chisel it in for this.
So as the particle moves faster and faster and faster, that would be a larger denominator.